to welcome everyone back for applications regarding automotive. And we are really excited to have kicking Ellen Lee. She's the technical leader of additive manufacturing for research and advanced engineering at Ford Motor Company. And she established Ford's dedicated AM research program in 2014. I'm going to bring her up on the stage now. And we will get this going. So thanks so much, Ellen, for joining us. And please feel free to take it from here.
It's my pleasure. Thank you so much. Let me just share my screen with you. Okay, hopefully everyone can see this. So let me just get started. It's really a pleasure to be at TIPE again this year. Ever since the inaugural conference last year, I've been looking forward to this year because it remains the best virtual conference that I have attended since the beginning of the pandemic. So I'm really excited to be here to hear about all the fantastic advances in additive manufacturing. So today I'm just going to highlight a couple of things that are new at Ford and in the automotive industry in additive manufacturing. All right, so first a quick review why we care about additive manufacturing in the automotive industry. I think most of you attending today are well aware of all of the benefits and advantages of additive manufacturing compared to traditional, conventional tooled manufacturing. For us in the automotive industry, these benefits of design freedom and toolless manufacturing are focused on those that you see in the middle of the screen here. The quick iterations that we can do compared to tooled manufacturing again, allow us to get to complex geometries in which we can have fully integrated parts and multifunctional applications, which means we have fewer operations. That means we have potential to simplify and make our supply chains much more efficient, while at the same time improving the performance, customizing our parts. And above all, I think the reason that we choose to use additive manufacturing is for added value, things that we are able to create value with and cost savings. So you see a couple of images of different examples here. Some of these I've presented in the past. They range in use cases from tools and fixtures to advances in materials and processes to parts that have really improved function or customization. And so in the next slide here, I've taken all of these types of applications, and if I don't talk about them in this talk or you're unfamiliar with them, feel free to ping me at some point during the conference and I'd be happy to discuss any of them in a little bit more detail. But of those applications, we categorize them in 4 main use cases for additive manufacturing in automotive. And these are shown here. Obviously, prototypes and engineering. We've been using additive manufacturing, like many manufacturing companies, for prototyping and the validation of new product design since the late 80s. And as the technologies, the materials, the processes continue to advance, we're able to go to more and more functional validation that only increasingly helps speed our time to market. In the next category, manufacturing tools, fixtures, and jigs, we have made a huge push to really support our manufacturing floor to make much cheaper, lighter weight, fast turn tools, lift assists, and so forth. And not only does this help us in those areas of time to market and lightweight parts, but they even increase the quality of the parts that we're assembling or that we're making. And importantly, they improve the ergonomics for the operators in our manufacturing factories. But it's the bottom 2 that give us the biggest opportunity for value creation. And those are when we leverage the design freedoms for performance and customization, as you see in the bottom left-hand corner, and then series production parts, as you see in the bottom right. And these two obviously have some overlap. In some areas, we have very low volumes where we're really focused on how to get that performance through the complex design. But we're also very, very interested in how do we get scalability. So it's really that scalability question that's at the forefront of our minds. And so
about what's new, and maybe
expand a little bit about what is not new. So the ultimate goal to achieve advancements in the technology towards scaling remains constant. But there are a couple of advances that we've made since the last time I was able to talk to most of you. And those highlights are listed here. One was a publication of the US CAR roadmap for automotive additive manufacturing. So US CAR, for those of you who are unfamiliar, is the United States Council for Automotive Research. And this is a collaborative where the US auto OEMs are able to pre-competitively get together to be able to advance big topics that need collaboration. And so while some of the areas that we need specifically in order to have faster acceleration and wider acceptance of additive manufacturing through the auto sector, while those needs are not new, our communication of them in this publication is new. And I'll cover some of the highlights in these 4 areas that I've listed here. Then I wanted to touch really quickly on sustainability. Again, sustainability is not a new concept for Ford. We've been at the leading edge of sustainability in other areas outside of additive manufacturing for quite some time. It's core to our DNA. But now that we've made significant advances in technology and production feasibility in additive manufacturing, we can turn more of our efforts into sustainability. And I'll just give one quick new example of that. And then finally, a little bit more fun, is looking at the use of additive manufacturing in personalization and customization applications. And so we'll show a couple of new use cases of that with additive manufacturing. So the biggest question in the manufacturing industry for additive is scalability. And the factors that influence scaling can be quite different from sector to sector. So what I'm showing you here is just a comparison of aerospace industry needs to automotive industry needs. And aerospace has enjoyed so much more success in implementing additive solutions. And it's because of some of these differences in the drivers. So although both industries have a high need or important need for high performance and long-term durability of parts and a range in part sizes from small to large, you see a huge difference in the scale or volume, where aerospace typically has thousands to tens of thousands of parts for high volume. Automotive is more in the hundreds of thousands to millions of parts for our high volume applications. But at the same time, we have a very high level of cost sensitivity. Our margins remain so low because we want our customers to be able to afford the products, that this combination of scale and cost is a really tough combination for us. The other important area that has different drivers for scaling is in the materials. So deservedly so, many of the materials that are available that are most prominent today for 3D printing are those that have been designed for the aerospace industry and the applications, exotic metals, titanium, Inconel, and so forth, as well as high performance engineering thermoplastics like PEEK and PEC. The automotive industry very rarely, almost never uses those types of materials. And we depend a lot more on the metal side, steels and aluminums, and on the polymer side, still engineering thermoplastics, but more in the lower melt temperature range and very high level of glass fiber reinforcement and not quite as much as carbon fiber reinforcement. The other area is in manufacturing. The rate or the throughput or cycle times that are needed for us because of our high volumes is a huge difference. And because we have a quite complex supply chain where more than one supplier might be supplying a part, we demand much more flexibility in our manufacturing value chain. And so that means that in quality, we need to focus more on how to build in repeatable, reproducible quality into the machines and processes and materials, and away from 100% inspection. And so a lot of these drivers went into the discussion to put together
map for automotive additive manufacturing.
So
What I'm showing here is the cover of the publication. And if you have interest in looking at
the details of the report, just go to uscar.org. You can search for Roadmap for Automotive Additive Manufacturing, and you should be able to download this article here. As I mentioned, this was a collaborative effort of the US auto OEMs and included several colleagues from each company, from Ford, GM, and Stellantis, and was facilitated by Energetics. So I'm going to go over relatively high level these 4 areas that I mentioned previously about what we really need in the automotive industry. So the most significant one, as I mentioned previously in that comparison of our scalability drivers, is automotive grade materials. So in many cases, those aerospace materials are over-engineered. So although they will perform to the requirements that we have, they will make it very hard to have a good business case for scaled production. And so what we really do need is cost-effective materials, and at this stage, more common materials so that we can help to develop a robust supply chain. In addition, the materials need to be more sustainable, including either renewable or recycled content, have lower embodied energies, or in some other way contributing to the circular economy. But above all of these materials need to be validated and characterized well for automotive use cases. So I have a couple of examples here with some details. And again, if you download the report, you'll be able to read all of this in much more detail. The next challenge is in manufacturing. So hand in hand with materials is the manufacturing processes. So in order to scale to automotive volumes, we need to improve the speed, cycle time, the throughput, the repeatability, and in many cases, the size of the hardware, in addition to the cost. Important to the repeatability and variability is automation and integration in our factories. So these are needed so that we can improve the quality and reduce any sources of variability that come into the factory. And this includes any post-print processes as well. So like materials, the manufacturing process also need to support sustainability, either or both, in low waste and low emission processes. So in design, many of the challenges in design are not unique to the automotive industry. In fact, I'll talk about some of the things that are challenges to everybody in the industry here. But because of the high cost sensitivity, design is the most impactful determinant for us of whether we can create value with additive manufacturing. And so we need to ensure that we have thought about a business integrated front end design that's integrated with the entire value proposition. And we need to ensure that our design workforce is versed in both additive manufacturing as well as traditional methods. And so these tools need to be compatible with common formats. So we can easily move from a part that is designed and made for conventional manufacturing alongside those and mating with those that are made with additive manufacturing materials and technologies. And then the final and fourth area is that of operations and workforce. And it's essential that we remember, as I alluded to just a second ago, that additive manufacturing is just one of the tools in our toolbox and needs to play nicely in the sandbox with our conventional manufacturing technologies. And so we need to ensure that these technologies are integrated into the facilities and interoperable with the same manufacturing execution system. And that means that they are subject in the factory to the same level of safety standards for materials and equipment. But we importantly need to develop, in some cases, new guidelines to account for unique risks for different types of additive materials and processes. For example, aerosols and powders, as you see in the safety PPE here on the slide. In addition, our operations workforce, just like the design workforce, needs to be well-versed in both additive and traditional automotive manufacturing processes in the factory. Okay, so again, if you want to learn more, please download that publication. So now I'm going to turn to sustainability. So I talked a little bit about sustainability in some of the other needs. Ford has long been a leader in sustainable solutions. I think recently, like a lot of other automotive companies, we've turned more towards electrification for sustainability reasons and have talked a lot about driving towards a circular economy. So in additive, now that we've shown a couple of examples of how we can achieve the technical, performance, functional challenges of using additive for production parts, we turn more towards how can we ensure at the same time that we make the processes and materials and products as sustainable as possible. So in powder bed processing, we are aware that we're working towards reducing the amount of waste for those powders that can no longer be reused back into the process again. And we know that through our iterative design and validation process that a lot of functional prototypes meet their end of life earlier than a production part would. And so at the same time, we're developing strategies to deal with these sources of waste. So in this example, we've taken PA12 from the HP process, both from waste powders as well as old parts, and recycled them into injection molded fuel line clips that go into our F-Series Super Duty. So it's just one kind of fun example for something that we can start to think about in improving sustainability while we work on the longer term, more complex technologies to solve it. So finally, I wanted to end on a more fun note. Additive manufacturing is a excellent tool to enable customization and even personalization. Everybody wants to put their mark on their own stuff, our vehicles included. And so with this in mind, we are starting to design our vehicles with that customer centric focus. Not everyone is alike. We know that not everyone will use their vehicles in the same way. And so with this powerful tool of additive manufacturing, what can we expect? What types of opportunities are there? So this animation just shows one of our newer vehicles, the Bronco, and it's a prime example of this. So in this animation, you see that we've designed the Bronco to be very modular. Many parts can be removed and swapped with other versions of parts. The doors, the fenders, grills, roof, windows, all of those are possibilities for aftermarket. And if we look to our customer, the aftermarket in customizing vehicles for either off-roading or overlanding or trail driving, even racing in some cases, all of these are possibilities for how you customize your vehicle. So I wanted here to show just one example. This is a concept vehicle. It was shown at SEMA, which is a big aftermarket show for the automotive industry, where builders put together different concepts of certain vehicles. So this one was shown in 2020. It's our Sasquatch concept of the two-door vehicle. And again, you see a lot of differences between this and the base model that you just saw in that modular design where the door has been removed. And in this case, we've put in some 3D printed content. You see on the exterior of the vehicle on the hood is our trail sights. So these help our customers as they're driving off-road to locate where the front of their vehicle is. But they also need to have the strength and toughness to be able to tie down things, towing, however one might choose to use their vehicle. And on the interior, we've also included 3D printed grab handles that you see here on the IP, as well as here in the floor console. So not only do they have a great aesthetic, they help, they're very strong, yet lightweight to keep those drivers and passenger inside the vehicle because we've removed the door here. So this gives us a very powerful tool to be able to think about how to make the vehicle exactly what we want for our use case. In other ways, we're also tapping into the aftermarket area with customization. For example, for our Mustang customer, those Ford Performance customers do a lot of aftermarket customization of their vehicles. This one example is for those customers who would like to race their vehicles on the track. They can replace their chassis spring with a dual rate spring that can give them better drivability and grip on the track, while at the same time on street driving, give them a little bit of comfort still. So in this case, our incumbent supplier for the spring sleeve, which is the elastomeric part that you see on the spring here, was unable to fulfill their orders. And these sleeves, their purpose is to protect the spring from any clash during the compression of the spring. So we used additive manufacturing as a solution for this opportunity. So instead of retooling, we're able to avoid the costs of $150K or more by directly 3D printing a TPU material with the HP process. And at the same time, we redesigned the part to have better performance. We put in these holes for improved water shedding, which in turn reduced the weight significantly. We were able to eliminate the adhesive and improve the ease of installation by designing in this helical structure with a slit that would grab onto the coil as it was installed. And we were able to, at the same time, reduce the part cost in that application. But if you look in the lower right-hand corner, you see this red part. So it gives us further opportunities to personalize as well. Anyone who's putting custom parts on their vehicle wants people to notice. So in addition to different possibilities in color, we see here also these cutouts for water shedding. This one went onto a Bronco. So you see silhouettes of Broncos cut out in that sleeve. So finally, my last example for customization and personalization. We bring this possibility into the DIY space. So this is the new small pickup platform called the Maverick. And again, we're focusing on allowing our customer to make their vehicles work for their lives with two unique features. One is called FlexBed, as you see here, and the other one is called Fits. With FlexBed, we designed in things like threaded holes and bolt-in C-channels here on the sides of the vehicles. There are several slots and pockets molded into the pickup bed here, so you can slide in dividers or any types of attachments with 2x4s. There are several power points with 12-volt power to maximize any accessories that you may want to put in, and any storage solutions. So we're really thinking about DIY. So in this next slide, we have an engineer talking. Oops, sorry. In this example, we have an engineer talking about customer options, depending on what that customer has, what their budget is, how they want to use their vehicle. So I'm going to play this little clip, and hopefully you're able to hear it.
With bike rack specifically, we love this idea of duality. So the bike rack accessory that we offer might be more than $200, but the do-it-yourself equivalent of the bike rack is around $45.
Right, so not only can you have certain accessories that are available for purchase, we can also really embrace that DIY to make those accessories exactly what we're looking for. And then finally, what I mentioned, FITS, which is the Forward Integrated Tether System. And this really enables 3D printing or additive manufacturing community. Simply what it is the slot that you see right here. And it's a standard slot into which you can slide in different types of accessories. This slot is located on the interior of the vehicle in the floor console. So this for the second row passengers, as well as inside the storage compartment that's underneath the seating in the second row. And as you see from some of the examples here, you can purchase accessories that have already been either printed or injection molded that fit into this FITS slot, anywhere from grocery bags to cup holders to dividers for storage and anything that you can dream up. So what we're doing is encouraging those DIYers to download the design of that FITS slot and then put together whatever it is they need in their vehicle. So in our internal community in product development, we had a design challenge that was exactly this. And our folks came up with things like airflow diverters to direct the air in the second row for air conditioning, cell phone holders, game tables, trash cans, pet food bowls, anything that those rear seat passengers would like. And in fact, I have one example here where we designed just a simple cell phone holder for the back. And you see we have the standard fitting that slides right into the slot. So we know that our customers know exactly what they need from their vehicle, and allowing them a way to implement it and attach it into their vehicle really allows us to give the customers passion for their vehicles. So I'll conclude today with just a recap of what's new and really what's not new. So the driving forces behind what our ultimate goals are for scalability and to communicate to the additive manufacturing community is not new, but the report is new. We want to be able to act with a unified voice to break free from this every project requires invention. What's not new is the focus on the circular economy, but what is new are some of the examples where we're doing just that to improve sustainability. And finally, I think everybody here knows that enabling customization is what additive manufacturing can truly do very, very well. And we hope that some of the design features that we put into our vehicle allow us to leverage additive as much as possible for customization. So that's it for today. I thank you for your time, and I am happy to answer any questions that you might have.
Thank you so much, Ellen. And we are just about out of time for this first presentation here. But if you want to take one of the questions, we can go ahead and do that.
Okay, so so I do see one question that's really upvoted about hardware size being a challenge. And the question is, what kinds of parts are being held back from being printed because of the size? And I think it's more of a combination of parts and process. So it's what you need out of the part. For example, in one process, powder bed processing, we see a lot of potential for scalability. And part of that isn't just that we need a hardware big enough to make one large part. We need it to be large enough so that we can nest many parts together so that we can improve the throughput of the parts. And so while we're still looking at relatively modest sized parts, in some cases they're large in one dimension and not necessarily in another, but we want the ability to be able to make many of them at a time because of the long print time per batch. So I know that it didn't answer specifically the question. So it's more about not the part itself, but the nesting, the throughput, and the potential for integrating applications together. So I know that we are out of time. I want to stay on track, so I'll end for now. But if people want to contact me outside with the general chat, I'd be happy to discuss further.